So today is a specialist talk, specifically about B12 deficiency and the genetics behind it. The genetics of behind B12 deficiency mean that you were born with a problem. Now, when I say a problem, what I must be clear about with genes is that we each have genes optimized for the things that we most need to worry about. So what you'll find is that Caucasians, i.e. white people living some distance away from the equator, tend to have fewer genes for being really efficient on B12 recycling and more genes for being fast and strong. And I think the reason behind this is that if you live on the equator, then vegetables grow. Therefore, part of your diet would be made up of vegetables. And therefore, being fast and strong isn't the most important thing with vegetables. But because you're not eating as much meat, you have to be more efficient with recycling B12 in case you run out. Whereas if your diet consists almost entirely of meat, then you're getting lots of B12 in from the meat, and we'll come on to whether modern meat's any good compared to ancient meat. You're getting plenty of B12. Your main concern is getting enough calories in, and therefore the pressure on your genes is to have the genes for the top 10 genes, if you like. The top 10 genes near the equator will include genes for being efficient with B12. The top 10 genes away from the equator will be for being a bit better at catching your food. So it's not that there's something wrong with you, it's that the genetic pressures are different. This was a way back when we started these drop-ins, which was during COVID. We introduced this. This is what these are about. What are we here for? And where are you joining us from? And you'll see at the top, it says join at mentimeter.com. And then when you join there, it'll say type in a code. That's the code to type in. And when you type in that code, it'll give you the opportunity to say where you are joining us from today. Is everybody happy to do that? I know some people are using your phone, so you can't connect to Mentimeter at the same time. Some people will be on a laptop without a phone nearby. But just to reassure you, this is a kind of, how are you doing? Are you able to connect? I hope people aren't having problems. I hope people are happy to tell us all about where they're dialing in from. So postal city for the UK, city and country for outside of the UK. Always exciting to see the number of places that we get people from. So 2 in the south, 1 in the southeast, 1 in the southwest. Off to a flying start. Well, you'll probably tell me they're both in the Midlands, will you? Oh, yep, Chicago. And all the colors are changing. This is really exciting. And I hope you like my background with a picture of the globe in. So 6 responses. There are, I should know how many of you there are. I think there's 36 of you, something like that. So a pretty good spread of people. Bucharest. So Bucharest over to the east and Chicago, USA over to the west. Oh, and Michigan. I don't know which is further. Is Michigan further than Chicago, or Chicago further than Michigan from the UK? One of the two. Yep, plenty of lovely places, plenty of places that are really nice to visit as well. And there's Maicas, Groningen. Yep, thank you very much. I'm going to move on to the next slide. You may be able to continue typing where you're from, but I'll move on to the next slide. Oh, New Mexico, I'm not sure which is the furthest across. This tells you how the coffee mornings work. They're obviously coffee evenings now. Join us on the computer, make yourself comfortable. I do an introduction to a topic, or in those days. Now we have speakers who do it, and then there's a conversation, a Q&A. This was a general slide that just introduces B12 deficiency. It's relevant for genetics. On the left-hand side, that is the endocrine system. So all the different, well, many of the different endocrine organs, starting at the top, the hypothalamus, thalamus, pituitary, the thyroid gland, the heart and its associated organs, the kidneys and adrenals on top of the kidneys, and so on and so forth. On the left-hand side, the second one along is that B12 affects DNA. So we're talking about genetics, but the genetics affect all 5 of these systems, and that's what we'll come on to. But B12 also affects your ability to replicate DNA and what your DNA is talking about when it's open. The third one along is removing toxins from the bloodstream. That's probably the most immediate thing that B12 does. If you get toxins in your bloodstream, the first thing, the B12 can be used up removing toxins from the bloodstream. So if you're in an environment where people are smoking, you might well find that you're B12 deficient simply because your B12 is being used up, clearing the smoke or the pollutants from the smoke out of your system. And the same applies if you're in an area of leaded petrol or leaded fuel or arsenic or all these other toxic things that really shouldn't be in your body. Your B12 can be used up just getting them out of your system, so you're still alive for the next stage. The nervous system, there's a brain and there's lots of nerves moving down the body, and then the gut, the whole digestive system, and B12 affects the gut, so it's a bit cyclic. You can't absorb because your gut doesn't work, which means that you don't have B12, which means your gut stops working, which means that you can't absorb. One of those things. So which body systems are affected for you? So endocrine is the hormones. So that can include how lively you feel, if it's the cortisol, early morning cortisol, but it also includes whether you have heavy periods or bleeding between periods, whether you have a low thyroid or high thyroid even, adrenaline or lack of adrenaline, and a whole lot of different things are affected by the endocrine system. DNA is impacted by if you've had or have had in the past, if you've had cancers. Pernicious anemia is mainly an autoimmune disease, although we will talk about the genetics of a genetic form of pernicious anemia. But all of the autoimmune conditions are affected, can be affected by B12. They can be caused by other things, but they can be affected by B12. The neurological, the nervous system, neuropathy, whether you lose the strength in your arms and legs, whether you lose feeling in your hands and feet, whether you have psychoses, or ringing or migraine. I believe even migraine headaches can be connected, and all those GI symptoms. So we're getting quite a pattern there, aren't we? How many have we got? 7 so far. I'll keep it running till we've got all 13, the 13 that said where they came from. Yes, you can see the actual, although you can see the average there, you can also see a profile of where people are putting their scores. And it's absolutely fascinating to see this. It's lovely to know that we're amongst friends, to know that we're with people who are sharing. It's not nice that you are sharing the same symptoms, but it's nice to know we're not alone. That's how I feel about it anyway. Okay, I'll carry on. What is DNA? DNA is this double helix, but let's go into some more detail about what it does. So DNA is coded information to make bits of you. Essentially, it's a set of letters that create words. It's quite a limited range, but each set of letters is combined into 3, And between that, they make quite exciting words. The words they make, or the sentences and paragraphs and books they make, are the proteins that run your body. So essentially, what you have is this a T connected to an a C connected to a G, or vice versa, joining together to protect themselves. But in order to read them, they're broken apart. So along comes something else called reading RNA, transfer RNA, tRNA, which comes and then reads the exposed bits. Then they join together again, and B12 is necessary for them to join together for them to be closed. But when they're apart, then you can read off a protein and you can say, right, that's the protein I want made, and it goes away and makes it. So if you're a thyroid gland up in the throat making thyroxine, then a message comes from the membrane to the nucleus and says, we need some more thyroxine. So the thyroid gene, thyroxine gene, opens up. The transfer RNA comes along and reads it, goes along, sees the messenger RNA, says to the messenger RNA, here's the code you need. The messenger RNA reads it, goes off into one of the organelles inside the cell and says, make some more of this. Makes some more thyroxine, that gets put out into the bloodstream. So on the whole, each cell, which they have about 20,000 genes in them, each cell is typically only got one gene switched on at any one time. I'll come on to why that might be relevant to cancer at a later stage in this conversation. But if you have one gene switched on at any one time, and most of the time it's switched off anyway, then obviously you're producing proteins quite efficiently, you're producing thyroxine quite efficiently. So in the top, see if my mouse works, if the top middle, you have that double helix, and it's then twisted on itself to make the helix itself. That then twists on itself to make a lysosome with histone proteins, which then twists on itself to make a chromosome. So you've got this really high density of information. I have had my whole genetic code sequenced, and it's 80 gigabytes. It's huge, and that's just me. And computers are currently looking at how to encode computer memory onto DNA, because it's a much higher information density than a computer chip, and it lasts much longer than a computer chip. They reckon that DNA lasts 10,000 years. Computer chips last between 100 years. The chip itself lasts between 100 and 1,000 years, and the information on it lasts between a year and 100 years. Whereas DNA can hold the information for thousands of years. Or we know about dinosaurs being able to extract the DNA and maybe do something with it. So we're looking at, this is very, very clever stuff. We're looking at actually harnessing computers up to make use of this genetic information. But it's not always right, and each of us is unique. There's a plug for the book. This is the connection with cancer. So there I've got a cookbook, and it's in a windy kitchen. Okay, so we've got a cookbook, we're in a windy kitchen. What this is as though there wasn't enough B12 to shut all the genes down. So more than one gene is open. In fact, a random collection of genes are open. So the tRNA comes up to the nucleus and says, what have you got for me today? And it looks at the page and it makes some of that. And then it comes back and it says, what have you got for me today? And it looks at the page and it makes some of that. And if you're making thyroxine, then everything's good. It goes into the bloodstream, it floats around the bloodstream. The pituitary says, right, we've got the right amount, stop producing. Or the pituitary says, no, we haven't got the right amount yet, put some more in. If you're just producing random proteins, then not only are you using a lot of energy because you're producing them very inefficiently, one bit at a time, but you're also manufacturing the contents of another cell. So 19,999 of the genes inside the human cell are for making other cells, and one is for doing the work that cell is there to do. So you can imagine, if you don't have the B12 connecting, holding down your DNA, then you could be producing other cells, which is also why when they've given B12 to mice with cancerous tumors, those mice have healed. The tumor starts to shrink again and turns normal. It turns back in from the undifferentiated tissue. It turns back into the tissue of the organ it's part of. And they have seen, in some experiments, they have seen mice actually being healed of cancer by high levels of B12. So it's completely reversible, but we can't prove it because we haven't been able to do experiments because it's considered ethically not permissible to not cure people using modern medicine. This is a quick diagram. I'm not going to talk you through this diagram. I'm going to talk you through some detailed representations of it, of the genetics I'm talking about. So up at the top, where you've got a blue and a green and you've got a red, we've got the mouth at the top, not drawn on this picture. We've got the esophagus, which is your throat, and it then goes into your stomach. And there's your stomach. So there are genes coding for the haptocorin in the saliva, which is going to carry B12 around and look after it. The blue and the green, blue CABL is cobalamin, which is B12. One form of cobalamin is B12. And the P is the normal animal protein, which we need to digest to use for protein, but also we need to take off the B12 in order to use it. So when it gets through to the stomach's busy producing this strong acid, which helps break down the proteins and other foods, and also, quite frankly, kill any nasties that are on your food. That's really what the stomach acid's there for, but it also helps with digestion. And then combine the B12, the cobalamin, with haptocorin and with intrinsic factor. So you can see we've got haptocorin binding in acid, intrinsic factor being produced in acid and in crypt cells in the stomach. And then when it goes out of the stomach and stops being so acid in the small intestine, which is that top bit, the bit immediately after the stomach, then as the pH changes, the haptocorin's removed and the intrinsic factor, which was produced in the stomach, is attached to the B12, which helps it be absorbed. And then when it goes down the small intestine, which is the ileum, we've then got a detailed picture that says that it's taken out of the ileum into the bloodstream, and the portal system is the bit of the bloodstream that carries it from the ileum through to the liver to be sorted. And when it's sorted, most of what you digest is oils and fats and proteins, and the liver doesn't want them floating around your whole bloodstream, so it takes all of them out. But the B12 it lets continue circulate. So all the blood that goes from your intestine goes to the liver for sorting, and then from the liver, the right bits are put into the rest of your bloodstream, including the B12, and the other bits are adjusted so that they can be sent for storage or used immediately. The food you eat. Right. So starting at the stomach. Two genes, the genes are in bold, two genes in the stomach. One is gastric intrinsic factor. This is the the GIF is the gene. Gastric intrinsic factor is what it codes for. And the intrinsic factor is needed for absorption. So there's a form of pernicious anemia, which is genetic pernicious anemia, where the gastric intrinsic factor gene has a fault in it, which means the intrinsic factor that's produced is faulty, and you can't absorb B12. You can't absorb B12 into your small intestine easily because fundamentally there's a problem with the intrinsic factor. This is not the same as autoimmune gastritis or pernicious anemia in most people's view, which is where the cells that produce intrinsic factor are damaged by the body's own autoimmune system. And the result is the same. There's not enough intrinsic factor, or there's faulty intrinsic factor, and therefore you have trouble absorbing it. But pernicious anemia usually develops from adulthood onwards whereas genetic pernicious anemia starts right from babyhood. You need to treat it right away. Then there's this FUT2 gene, which affects a number of proteins. They affect H. pylori attachment to the walls of the stomach, which can affect whether you get ulcers or not. Next step down is the next one down, the small intestine, which we've talked about. So there's cubalin, the protein, CUBN gene. Cubalin is needed. It sits on the walls of it floats around and binds to the B12, and the AMN gene for amnionless. I have no idea how to pronounce that, and I don't know what it means, which binds the cubalin to the intestine wall and helps absorb it. And there we've got a syndrome for when there are faults with those genes, which again makes it difficult to absorb the B12. So all of this first stage on the left-hand side, this is all about getting the B12 from your food into your bloodstream in the first place. The second half of this slide. So the second half is when we come on to haptocorin, which we've already talked about in the saliva, but there's a haptocorin in the bloodstream as well. I think they're identical, and transcobalamin too. Haptocorin, it seems the B12 doesn't usually float around by itself. It's either bound to haptocorin or it's bound to transcobalamin 2. Transcobalamin 2 is the active form, and haptocorin's the inactive form. We have a theory that the haptocorin form goes into the liver to be pushed into the bile duct and therefore into the small intestine to be reabsorbed in order to activate it. So you can't go from haptocorin bound B12, inactive B12, to active B12 in the bloodstream. You have to do it through the gut. Now, this is important because this starts to explain how it is that when people become B12 deficient, they suddenly need much, much more B12. It's because that in order to activate the B12, it has to go through the gut. And if you're not absorbing very efficiently, then it's going into the gut and it's not coming back out again. It's going out in your poo. An early cure for B12 deficiency was drinking your own poo. And whilst you might think that's disgusting, I have to say it's a whole lot better than being dead. So that's where getting it working in the bloodstream, that's where functional B12 deficiency comes from. If you can't get the B12 in an active form, then you can have high levels of B12 floating around in your blood, according to the measurements, but it isn't working. You're not feeling the benefits of having all that B12. And then where the rubber hits the road, where the B12 actually gets used, is inside the cell. And that's what all of the previous three processes are trying to do. They're trying to get it to the cells and inside the cells so that the cells can get to work and do something with it. So we have CD320, which codes for the transcobalamin receptor gene. Transcobalamin receptor protein, which sits on the surface of the cell, facing out towards the blood or facing out towards the plasma that floats around where the outside of the bloodstream, and binds to the transcobalamin B12 whilst holding on to it's in the membrane, and it sits there and it holds on and it says, I've got some B12. All these proteins that sit in the membrane of the cell change shape when they do something. So when it attaches to B12, it changes shape. And when it changes shape, it's like putting up a flag. It's turning around to the ABCD4 gene, which codes for an ABCD4 protein, and says, I've got some B12. And the ABCD4 says, give it here then. And drifts across, grabs it, and puts it inside. So the ABCD4 protein is a hollow protein that can take B12 from the outside and take it through to the inside. And the thing to remember is B12 is the largest molecule that is absorbed from the gut. So proteins are much bigger, but they don't get absorbed from the gut as proteins that get absorbed from the gut as little amino acids. We talked about the genes, where we talked about putting 3-letter codes together into a 3-letter code. That letter code codes for a single amino acid, and proteins are broken down into 1, 2, 3, and probably 4 and 5 length amino acid lengths of bits of protein, and that's what's absorbed. So it's much smaller than B12. Starches, similarly, they're broken down into sugars, and the sugars are quite small. So the stuff that goes across the gut wall is quite small, and the B12 is the largest molecule to try and get across the gut wall, which is, of course, why we have problems absorbing it if you have anything wrong with your gut wall. And then the LMBRD1, coding for the LMBD1 protein, assists ABCD4 to actually get the B12 from the outside of the cell to the inside of the cell. So those are the genes that work on transport. These are the genes that work inside the cell. So you've got the genes are in capital letters in italics. And there's a lot of them. You can see up in the top left, you can see ABCD4 and LMBD1. There's a bit of reassurance. You know that one of our old friends is still there. Then we start with a whole lot. I'm not going to go through all this in detail. What's important is to highlight the difference between the cytoplasm, which is most of the cell, and the mitochondrion, which is an organelle inside the cell in the top right-hand corner of the cell. And cells are obviously round, not square. Well, actually, no, it depends what the gap is. They're whatever shape the gap is that they're in. And if they're between a whole lot of other cells, then they're all squished together. If it's a nerve cell, for example, a nerve that feels whether you've stubbed your big toe runs the full length of your body. It's one single nerve that goes from your brain to the tip of your big toe. So you can imagine that's not very square. That's kind of long and thin. In the mitochondria are the bits of your body. Mitochondrion is the single, mitochondria is the plural, are the bits of your cells that produce all the energy. They produce all the energy that drives everything else. And you can see the B12's going in there through various genes. It's working its way along through various genes, MMAA, MMAB, which converts cobalamin 3, which is a particular form, a particular activation of cobalamin into adenosylcobalamin, and adenosylcobalamin, the ADO-CBL. Adenosylcobalamin is the form that is active in the mitochondrion. So when you have trouble converting from hydroxocobalamin to methylcobalamin and adenosylcobalamin, then that's when you take methylcobalamin and adenosylcobalamin in order to have the adenosylcobalamin available, because you can't convert to it naturally. And the adenosylcobalamin then does a whole lot of things, particularly the succinyl-CoA to methylmalonic acid, methylmalonyl A, and also the acetate to methyl-CoA. These are all driven by having adenosylcobalamin there to carry the energy to help form these changes. So what you've got is inside the cell, you've got some things that create energy, mainly in the form of ATP and ADP. Well, ATP is the triple form, which is the high energy form. ADP is the form that's used up, that goes back to be recycled as ATP. You've also got various other carriers of energy for particular purposes. So they're a bit like catalysts, but they're a whole lot cleverer than catalysts. They actually carry their own energy as well as doing the bringing things together. The body is a whole lot cleverer than human beings have got to so far. I see a lot of people working on, for example, special biologically engineered systems that can convert sunlight to sugar. And I say, yeah, we've got plans for that. Why are you bothering creating something new? But maybe that's me being an old grump. I'm old, I'm allowed to be a grump. Then in the cytoplasm, that's when methylcobalamin is used. So adenosylcobalamin in the mitochondria doing all the energy, methylcobalamin in the cytoplasm doing various other things, there. You see in the center there, you've got cobalamin in the one state form. You see it's all the cobalamin in the three state form in the mitochondria directly above it. Cobalamin in the one state form to the cobalamin in the two state form to methylcobalamin using the MTHFR gene. The MTR is there on the left of the cobalamin 2, which is another gene, and the MTHFR is actually a folate gene, but folate and B12 do a lot of things together. One of the things they do together is that the methylcobalamin donates methyl groups to the DNA in order to shut down genes, and it needs folate to get the methyl groups, because B12 is very, very efficient at giving methyl groups to DNA, but not very efficient at finding methyl groups to give it. So it turns around to its mate folate and says, methyl folate says, here's some methyl for the B12, and methyl folate's very good at going around the system, or folate's very good at going around the cell saying, I see you've got some methyl there, I'm going to nick it. And then brings it over to the methyl, or the cobalamin that's waiting for methyl, and says, I've gone out and got you some methyl so that you can do your job. So there's a whole lot all working together. Now, each of the previous genes, there are more efficient and less efficient alleles or versions of those genes. So the name we see here in italics is the name of the gene. That's the name of the position on the chromosome. For each position on the chromosome, there are a number of different forms that the gene can take. They're usually very, very similar, but they have slight variations. And those variations, sometimes they're just plain not so good. Most of the time, they're specialists for different situations, so they might work better at different temperatures. If your average external temperature is different, they might work different with different diets. So they have developed to be perfect for a specialist situation, and in modern society, that's not so relevant to us. I'm going to see what else we've got. You can see on the left, you can see an agouti mouse. An agouti mouse is essentially a tennis ball with feet on. It's fat. It's bred that way in order to be used for testing obesity drugs, heart disease drugs, and diabetes drugs. These mice come with an instruction, don't let them eat B12. If they get B12, they come out normal. See a picture of mouse on the right. Obviously, they're not the same mouse. They're two friends, but one's had B12 and the other one hasn't, which tells us immediately that the genes are there for the mouse to be normal. It's just unable to express them because it doesn't have enough B12 to express them. So we're not talking large amounts of B12. We're talking about restricting their B12 completely if you want them to stay useful for testing drugs. And that's really quite important, because it says B12 is important for allowing the right genes to be expressed. So all the stuff you'll get on epigenetics and all the rest of it, if you haven't got the B12 there, they can't express the gene you want. Or if you want to express a non-normal gene, like being round like a tennis ball, then they can't express the normal genes because they haven't got the B12 to express it. So that's another reason to have the B12 floating around in your system. Unfortunately for us, everything else gets precedence over DNA, because DNA takes time to express, whereas toxins in your bloodstream, there's not a lot of point in avoiding cancer if you're going to die of poison. So the B12 gets used up first to get rid of the poison, then it gets used up to get rid of the autoimmune disease and work with your endocrine system and work with your neuropathy, and then it gets used up to work on your digestion, and it's a little way down the line before it actually comes to looking after your expression of your genes. So you need plenty of B12 to make sure it's getting through to your genes. And what was the other thing? Oh, inside the cell, there's a thing called homocysteine that no doubt everybody's heard of, and there's a thing called SAMe. S-adenosyl methionine with an E at the end. And homocysteine is the depression hormone, and SAMe is the happiness hormone, or they are chemicals that have that effect on you. Why would you want a depression chemical inside you? Well, if it's the middle of winter and the only thing outside is a polar bear trying to eat you, then the best thing to do is to sit in the corner keeping quiet. Whereas when springtime comes round, then you want your happiness hormone that says, oh, I fancy going outside again. So depression, again, has a purpose. But B12 has a direct connection. It directly converts homocysteine into SAMe, and that's why when you test for high levels of homocysteine, it's a good specific predictor of if your B12 is low, then you can't convert it. And it's a good specific predictor to say if you've got high homocysteine, there's a good chance you've got low B12 or low functional B12, even if you've got high B12 in the blood itself. B12 is inherited. You'll see people, these are the first in name initials, and I can't remember the names in any way. I wouldn't be able to say it because that would break confidences. The one that's in red and underlined has B12 deficiency. So you'll see a very widespread prevalence in the population of B12 deficiency in Dr. Chandy's practice. And so the Florrie and Fred, or whoever they were, had 3 children, 2 of whom were B12 deficient. B12 deficient people, I think it's just because of the sheer number of people out in the population, married, in one case married a B12 deficient person, and once again 2 with B12 deficiency and 1 without. The B12 deficiency arriving in the rest of the family, and so on to the 4th generation in this case. And obviously we couldn't test earlier because we didn't have a way of testing earlier. But it really does run in families. Another plug for another bit of the book. Let me just find, if I can, find the chat and put it where I can see it and see. So Hannah has said, I've tried hydroxocobalamin injections and it seemed to give me terrible anxiety and panic. So we think, and I don't think it's the inability to convert into methylcobalamin and adenosylcobalamin. We think this is a thing called reversing out syndrome, which affects about 1 in 10 people when they start their B12 deficiency replacement therapy, when they start their cure. The reason we call it reversing out syndrome is because we think you go back through the symptoms you went through to get deficient in the first place. You end up with deficiency, which is a kind of numbness. But to get there, you've often been through a certain amount of trouble and pain. And we think the reversing out syndrome is kind of going back through those symptoms. And very common there are anxiety and palpitations. I say very common. We're starting with 1 in 10 people on treatment get reversing out syndrome. The most common of the symptoms that occurs is a rash on the skin. So these nervous symptoms is going to be less than 1 in 100, or it's going to be around the 1 in 100 mark of the people on treatment will suffer from that. And really what you want to do is keep taking B12 until you get to the other side of it, which shouldn't take longer than 48 hours. Does sometimes, but it shouldn't. I hope that makes sense. So yes, it's awful. It is common enough that we've documented it, and it's common enough that we've documented people getting to the other side. And if you don't get to the other side, if you keep backing off, then every time you have B12, you'll suffer all the reversing out syndromes, as you'll be bumping along, going into the improvement, dropping down, bumping back into the improvement. Whereas if you can just get above the improvement, then you'll get your life back. Right. There's a lot of genetics in pregnancy. We've created a new person. So people talk about neural tube defects during pregnancy. One of the difficulties has been that we supplement with folate and we don't supplement with B12, and folate masks the poor B12. There's, apart from the spina bifida, which is the full neural tube defect, there are much milder impacts, and those impacts can be very upsetting for those who suffer from them. So we strongly recommend plenty of B12 during pregnancy. And the first condition to be treated in the BNF, British National Formulary for Children, was B12 deficiency in children. The BNF, the British National Formulary for Children, was created specifically to address that the adult version could only say above 16 and over. The new NICE guidelines say 16 and over. So the BNF for Children specifically started up to say, by the way, don't be afraid to treat children with B12 deficiency, or actually just to treat children with B12, because it doesn't matter. So reversing out syndrome has been compared with Dr. Lonsdale's paradoxical reaction in regaining health with high-dose thiamine. So absolutely, I would not be surprised if there are similar effects from a whole lot of different nutrients that commonly go into deficiency. And thiamine B1 would be another example of this. Most of the things that go in our bodies happen in a number of different situations. The hepatic portal system, where the B12 is taken out of the blood, put into the liver, then into the bile, and then into the small intestine for reabsorption. Again, very common. Lots of different substances go through that cycle. It's not unique to B12. And it's one of those things that we need to keep an eye on. Why don't we treat B12 deficiency? I have no idea why we don't. When someone is thirsty, we don't say, let's get two of you and give one of you water and see if he's still thirsty and leave the other one still thirsty. We simply say, here's some water. You'd think we'd say, when someone presents with B12 deficiency, we'd say, rather than saying, oh, we've got to do a clinical trial, you'd think we'd say, we can see it's deficiency, let's give them B12. It's one of those things that's a bit beyond me. But for treatment, tablets, tablets, cyanocobalamin, we reckon that 2/3 of people are fine on tablets in the first place. 2/3 of people who need B12 are fine on tablets, and 1/3 need injections. We reckon that most people are fine on cyanocobalamin on tablets, but some people aren't. I'm one of the people who can't remove the cyanocobalamin, the cyanide group from cyanocobalamin, and therefore I can't convert it to a form which I can use to make into methylcobalamin or adenosylcobalamin. But about 1/3 of people need injections as needed. Of those 1/3, at least 1% need it daily, which is, 1 in 100 is a big number. But typically every 4 weeks we say, for the purpose of giving people a sample, an idea, hydroxocobalamin is the standard format in the UK, cyanocobalamin is the standard format in the USA, methylcobalamin is common. Adenosylcobalamin by injection is rare. It's not easy to get, and it's not easy to handle. Even adenosylcobalamin by tablet, I find that I can only take the powdered stuff in a capsule. The adenosylcobalamin in a tablet doesn't work for me at all. That may be personal, or it may be adenosylcobalamin is a huge molecule because the adenosyl group's bigger than the rest of the B12 put together. So I can see it needing a lot of care. I say take it with a multivitamin. A lot of people say you need specific nutrients, specific supplements, but you will need to find what works for you because everybody's unique, and you can't overdose on B12. Have both injections and tablets. That's what I do. Back to you. What inherited symptoms are in your family tree? Pernicious anemia on the left, infertility, heavy periods, bleeding between periods, fatigue or sleeping a long time, neuropathy from birth, and damaged folate mechanism. Meanwhile, while you're filling that in, I will answer some of the questions. Did Dr. Chandy have patients who needed injections more than every other day and who recovered very slowly? Yes, we had a patient who came in with, who came in a wheelchair, teenager in a wheelchair, having deteriorated really quite rapidly, and started on alternate day injections. And every time we reviewed, every week we reviewed, there was something else that had improved. So therefore, she hadn't finished improving because it's B12 injections, alternate days until no further improvement. And it was 10 months of alternate day injections before she walked without a crutch. That's no wheelchair, no crutches, walking without steady improvement or intermittent improvement, but at least every week over 10 months. We had someone who was at a football match and had to take his hearing aid out and found he'd been deaf since birth and found he could hear. And I think that was over a year worth of B12 injections. So yes, some people recover slowly. We've certainly had patients who needed to inject every day or needed to inject twice a day even. ALS is a syndrome that seems to require extremely high levels of B12 to pretty much stop all the symptoms. We never got to explore it all that much because of the sheer difficulty of getting that kind of quantity of B12 and making it available to them. But they'd done a bit of research on the web and they'd found it and it worked. Sally says that Southampton Hospital says that B12 deficiency doesn't exist in children. You've mentioned a mutation of the TYR gene. There are probably loads of genes that have loads of connections. I've talked about the ones where there's absolutely clear evidence of a connection, but there'll be all sorts of connections which won't be as well understood. They might still be really, really clear, but we don't understand them yet. Does folate deficiency anemia benefit from increasing B12? This was one of the first exciting findings that Dr. Chandy made, and it's mentioned at the beginning of the book, where he found, without trying, without even looking for it, that when he started treating people for B12 deficiency, even without doing anything about their folate in their blood returned to normal levels. So B12 tries to make you normal. I'm not talking about boring normal. I'm talking about as normal as you'll ever be. B12 tries to make you normal, and that means adjusting the levels of things in your blood. Hannah asks, how do I know if I need injections or tablets? You have to try it. Nobody really can tell us up front. Nicola asks, how do I vote? I hope people have found out how to vote now. It looks like we've got the 13 votes that we were expecting. The instructions are, you open a browser on your phone, you type mentimeter.com, you type the code that's at the top of the page, and it takes you through to the questionnaires and lets you vote. Sue asked, why don't doctors recognize that there are various forms of the B12 molecule and many analogs, and these can skew the results? It's a constant battle. Don't have a way around that. We're constantly saying, not just that different forms of cobalamin. So there's only one form of cobalamin that's B12, the one that can be used in animals. There are lots of other cobalamins. Cobalamins basically are a cobalt atom in the middle of amine rings. Cobalt, amine. And they all, most of them are a circle of 4 amine rings surrounding a cobalt atom, but they have different shaped tails. And the tails are mostly not usable by animals, including humans, and only one can be used. But there also appear to be other things that also trigger the test. So the test is saying, this is how much B12 you've got, but the test is actually saying, I'm detecting a particular thing. We're not quite sure what it's detecting. It might be nothing to do with cobalamins. It might be something else it detects. It's just a test. It shines a light through, and it might pick up something totally different and say, oh, this is B12. Nicola responds that she's got all of those symptoms. Doesn't surprise me at all. They often go together anyway. And I've now got 11 messages. Lisa asked me a direct message. What's the logic in taking a pill and an injection at the same time? I don't like to inject every day. I inject twice a week. That's just laziness on my part. It's inconvenient having to fill the syringe up. So I take the tablets in between times. Also, I haven't found an easy way to obtain adenosylcobalamin for injection, and I have found that the capsules with powdered adenosylcobalamin work just as well as when I did get some. I got 5 injections to try them out of adenosylcobalamin. You can't get mixed adenosylcobalamin and methylcobalamin in an injection. It's simply not possible to put them in the same solution. If someone says that they've got it, they're probably fibbing. You can get methylcobalamin and adenosylcobalamin in the same tablet. Doesn't work for me. I find that if adenosylcobalamin is compressed into a tablet, then it stops working for me. And I think there's a few other people finding the same thing. So I recommend not taking the adenosylcobalamin, methylcobalamin combined tablets. I recommend taking them separate. But that's a personal opinion. Sue describes that we're very lucky to have her, which is absolutely right. We are very lucky to have Sue. How do you know how often to inject? Unfortunately, you have to find out for yourself. What you do is you start by saying, does it work when I inject alternate days? If it works when you inject alternate days, then you've probably got B12 deficiency. If it's not making any difference when you inject alternate days, then it's probably something else, not B12 deficiency, or it might be a combination of things, but there's something else that needs to be addressed first. Not everything is B12 deficiency. So you start by saying alternate days, and then you say, what happens if I leave a week between injections? Do I start to see symptoms coming back? And we recommend that you keep a symptoms diary, and the easiest way to keep a symptoms diary at the moment is to have lots of copies of the Appendix A from the book. So photocopy it or usually photocopy it and write them in. Make sure you put the date on. That's why the book has a very clear space for the date to go on so that you can see how your symptoms change. And then you can look at your symptoms and you can say, do I have a marker symptom that says that the symptoms are about to get worse? Something I hardly notice. But in reality, it's the symptom that first appears that shows when my symptoms are going to get worse. How many days from an injection is that? Because what you'll find is for the first few weeks or months, you'll be injecting quite often as the only way to keep your symptoms fine. And then as you get the levels of B12 up in your blood and up in your system in general, you might well find that you can cut right back on how often you need to inject, which saves turning yourself into a postage stamp, which is nice. So it is worth keeping a symptoms diary if you possibly can and saying, do I have marker symptoms that say it's going to get worse tomorrow? And therefore, I might as well do the injection today rather than wait until it actually gets worse. Work on that. So Micah says that she mixes adenosylcobalamin and methylcobalamin in one syringe. I believe you'll find that some of it precipitates out. Adenosylcobalamin needs to be in a much lower pH than methylcobalamin. So I believe you might be creating a problem by doing that. Not a problem that's dangerous in any way, but a problem that it might be deactivating one or other of them in the course of mixing them rather than putting them into your bloodstream separately. That's certainly what I was advised when I was sent a batch of adenosylcobalamin to try out. Mansuki says, is it true that once a patient is put on 3 monthly injections, this must not be stopped? It isn't true. you might find, it's very unusual, but you might find that you are completely cured. Now, I'm not saying you go to your doctor and admit that. You might say, oh no, absolutely. The British medical guidance is that once you're on B12 injections, they're there for life, and you should keep having them for life. But the reality is that some people really do restore all their problems. So they might have some genetic factor, or it may primarily be an autoimmune factor. And if there's a whole lot of autoimmune damage that then gets cured because there's enough B12 for your immune system to go back to normal, then you might actually not need any more injections. But I have to say that is pretty rare. And we certainly don't recommend going to your doctor and saying, oh, don't worry about giving me injections because I might be cured. So just to reassure people that some people do find that their requirements drop right off or even become zero, but it is pretty rare. So Mike has explained where the methylcobalamin and adenosylcobalamin came from, and that's absolutely right and works really well. And Arnica Apotheke is a very good supplier. It's one of the ones that we used to use. Extremely good, very reliable. And for people who are buying it in the UK, if you have any trouble because they reject a UK address, which they sometimes do, then use your PayPal account. So you don't put an address in, you just log in on your PayPal account or offer to pay on your PayPal account without putting an address in at all. Somehow it picks up the address from PayPal, and for some reason, when it picks up the address from PayPal, even if it's a UK address, it says, yep, spot on, that's fine, we'll let you buy. Even if it previously said, oh, you're from the UK, we don't supply to the UK. So there are ways round the blocks. And as you can imagine, I'm keen to make sure I get what I want, which tends to mean I look for ways round the blocks. Sue asks, would getting the MHRA to acknowledge that B12 is a nutritional supplement make it easier for them to allow over-the-counter purchase? So the difficulty for the MHRA is that you can sell or buy B12 as long as you're buying a supplement with no specified benefit. So you'll notice if you're buying B12 for injection, most sites say you can buy B12 here. They don't tell you what it does. They very deliberately don't say that it does any good. They can't claim it does any good if they're going to sell it. Our charitable aims are that we raise awareness, and therefore we're not going to say we're going to stop saying it does any good. We're going to carry on saying it does some good, and that's why we had to stop supplying B12. We were supplying it free of charge. People very generously gave donations that covered the cost, but we were warned that if we went on saying it does some good and supplying it, we could be jailed. And I didn't really fancy being jailed, so I said, okay, we'll carry on saying it does some good and stop supplying it. The MHRA is quite happy that you can buy it at a beautician's or in a gym. They're not happy that someone says this actually does some good and then tries to supply it. Weird, but that's just the situation. And Mike, I would be interested, Mike, you said you'll stop mixing them. I would be interested to hear if you think it made any difference. My information might be wrong. I'm not the fount of all knowledge. I'm just expressing what I've researched and what I've found in my research. It would be really interesting to find out if there was any sanity to my research. Nicholas talking about symptoms. What's really interesting is the recovery. So very often, once people start taking B12 and start to recover, they don't notice their own recovery. Very often, it's your friends. So your friends will say you're much more sociable. You will say they've stopped being irritating. Your friends will say you're a lot less irritable. You will be you've been saying, I wish everybody would go away, and they start saying you've become a whole lot more sociable. You won't notice it because you're in the middle of it. as far as you're concerned, the world revolves around you. I mean, it's true of all of us. It's true of me as well. The world revolves around me, and therefore everything I do is perfect and whatever. And it's other people who are annoying, and they'll be saying, "Oh, well, now we can tell when you're on your treatment," or if it's your kids, we can tell when you're short and you need some treatment because of the fatigue, because of the irritability, because of the um, because you just start feeling worn out, but you don't really notice it. And the webinars, for those who haven't been on one before, they're every second Monday at 7 p.m. UK time. If you want to get notices of the webinars, then email to notifications@b12d.org. On the subject line, please type newsletter sign up, or go to the website www.b12d.org and click on the button that says newsletter sign up, which does exactly the same thing. It creates an email, puts the subject line newsletter sign up, and sends it to me, so that I can then add you to the newsletter. That tells you what webinar's coming up next Monday, the next time, second Monday, 7 p.m. UK time, and we've got a WhatsApp. And if you want, and I can also add you via this form, which nobody can see what you're typing except when you've finished it, I'll be able to see them. I'll add you to the newsletter and send you a link to the WhatsApp group. So I'm going to pick up on Helen. Helen comments on Dr. Klein in Cambridge. Dr. Klein is a great friend of ours, and we have a huge respect for his clinic and for his work. So absolutely, he's a great person, and he's right to say the cutoff should be around 300. We think 350, but even then there will be people who are missed.
I've been consulting Dr. Klein since August last year. I've sort of got a long history of being ill. Over 30 years I've had ME, and I felt the fatigue was getting worse a couple of years ago. So I had some private blood tests with Medichecks, and one of those for methylmalonic acid was very high. It was about 67.3 when it's meant to be below 32. So over the years, I've not really sort of got very far with my GP, but I did go to him at that point, and I'd read all the NICE guidelines, and he did agree to me having the loading doses, which made me feel even worse, actually, much more fatigued for about a month. But I did feel like, Greta, you've been mentioning about your feet. I'd been getting pains in the arches of my feet, and that did seem to improve. So my feeling was I probably needed to continue with the injections, and that ended up with me consulting Dr. Klein. He's got like an online questionnaire that's meant to take about 2 minutes, which I think he's derived from Dr. Chandy's book. And so I did that one day, and he texted me back within a few hours and asked me to give him some blood test results, which then led to me having a Zoom consultation, which is very good. You don't have to get to Cambridge. He'll do an online consultation, and and he recommended I self-inject twice a week. So I've been doing that subcutaneously, and I've recently done a DNA test with a company called Lifestyle Genomics, and got a very long report back from them. And tomorrow I've got a first appointment with a nutritionist and a functional medical practitioner, because Dr. Klein had recommended I consult a nutritionist, because my B12 deficiency isn't due to autonomic things. He says it's to do with poor absorption, and recommended I see a nutritionist. So, it'll be interesting to see what she says tomorrow. I seem to have a lot of red snips, which is where both alleles are, possibly not very good. So I've got the MTHFR C677T. That's a red snip, and I've got MTRR K350A. So I'm currently injecting hydroxocobalamin. It sort of made me wonder, whether I need to change my regime, like you, Hugo, with the methylcobalamin injection. Anyway, I'll see what happens tomorrow. So that's me, yeah.
So do consider, a lot of people who are having methylcobalamin because hydroxocobalamin doesn't work find that they need adenosylcobalamin as well. They often go together. So if you can't convert from hydroxy to methyl, there's a good chance you can't convert from hydroxy to adenosyl either, or methyl to adenosyl. So you need to take them as supplements. I first heard about it when someone said the methyl's not working, I'm taking dibencoxide. And of course I thought, what's dibencoxide? Turns out it's a brand name for adenosylcobalamin. And so I thought, oh, this is interesting, I'll take some of that. And at that point, I was middle-aged and given up running. And now I've taken up running again. So it's worth a try. You might take up running.
Yeah. Well, possibly. Yeah, thank you.
Could you repeat that, please, Hugo?
What adenosylcobalamin? Dibencoxide is the other name for it, spelled exactly as it sounds with an I. Dibencoxide. Adenosylcobalamin. I take it as capsules in a powdered form inside a capsule. I find when it's compressed into a tablet, it stops working for me. So the physical form matters to me, and other people have reported similar things. They're cheap, Don't go spending loads and loads of money. Get cheap ones. But I also find that you can get mixed tablets with methylcobalamin and adenosylcobalamin in, and I find they do me no good at all. They don't seem to even work as well as methyl alone. So I take them as separate. So I take methyl and adenosyl tablet and capsule every day, and I inject twice a week with methyl. And because of the difficulty in the past of obtaining adenosylcobalamin for injection, and because the capsules work very well for me, I stopped injecting adenosylcobalamin. Just with the sample pack, I decided I didn't need it really. But everybody's different. Some people need it. Lisa B has mentioned, and I wanted to pick up on this, high B12 with zero administration of B12 at all. Now, the reason I want to pick up on that is high B12 is without external administration of B12 is usually a sign that your body thinks there's a problem. And therefore your body is putting more B12 into the blood to get round to that problem to stop it getting any worse. Our bodies are very clever. They do things proactively. And some of the things, I don't want to scare you, but I am obviously keen to make sure that you get the right treatment. There's a strong association between high B12 without any external B12 coming in, extra supplements, and colon cancer. But there are other things where I've heard people with high neuropathy, high anxiety, who also exhibit high levels of B12 without taking any supplements. So I think it may well be that with neuropathy as well, that the body says we need more B12 going to the nerves to cure the high anxiety, and therefore we'll put loads more B12 into the blood so that it's there for the nerves. Now, that's if it's using all your stores to get it into the blood in order to cure things, then you'll still need to take tablets to restore your stores. But they should be testing for things that the body might be concerned about, that it might be putting the B12 into the blood in the first place for, because that B12's high for a reason. Does that make sense?
Yeah, this was about 12 years ago, and it was rising and rising from 600 to 900 to they stop at 2000. They don't record after that.
Yeah.
And I thought, oh, I'm doing really well with my nutrition, not realizing I wasn't, it's not a nutrition-based thing for me as a vegan. And I was obviously Googling and terrified it was leukemia. Doctors just didn't seem bothered or concerned, other than to tell me, well, you don't need a supplement. Prior to that, I'd been on injections for decades, but irregular. No one ever told me to do it every 3 months. I just went when I felt really tired.
Yeah.
And now it's that they are allowing me injections, as I've said before. But yeah, I think, and my question was, the doctor still says to me, if it's in your blood, you have B12.
Yeah,
And
you do. Absolutely. Well, sometimes in part you have it. In part, the test says that you've got something in your blood that the test detects. So if, for example, we look at a pile of white powder on the table, then we can't say we've got plenty of sugar. If we've got no white powder on the table, then we can say we've got no sugar. Does that make sense? So if the test isn't detecting B12, it's detecting something, which happens to B12 happens to be one of the things it detects, then what we can tell, if we've got a huge amount of it, is that we've got something, but we can't tell whether we've got B12 or not. The test is just not very accurate anymore, not very specific, I should say, anymore. But that's beside the point, because even if you have high levels of B12 floating around your blood, is it getting into your cells? And if you've got symptoms that show it isn't getting into your cells, then you've got functional B12 deficiency, which is masses of B12 floating around in the blood, but it's not able to be used unless you get a higher level. So that's why we've got
how
this
does the injection get into the cell quicker
basically.
than...
So the injection takes your levels up to a simple injection is instantly 14,000. As you say, the test doesn't tell you it goes above 2,000. It stops at 2,000, but the injection straight away is 14,000. So all it really does is it pushes the level of B12 in your blood to such a high level that some's bound to get into your cells. And it just means that by pushing the level of B12 in your blood to very high levels, then your cells are able to make use of what does get through. And that's why people have such different levels of B12 in their blood, because their body understands how much they need. If it's available in stores to put into the blood. Does that make sense? So you will get much higher levels of B12 in your blood if you have injections than you can possibly get from your digestive tract. Is it
what I
dangerous?
could never seem to explain to the doctor is how it's then utilized.
Yeah, so that's a matter of how it gets across the cell membrane and how it gets into the cell, which depends on the genes, and that's why we talked about the genes that transport it across the cell wall.
Yeah.
Because some of them work well and some of them don't work quite so well. If the doctor's got concerns, ask him to use, so that all doctors have the BNF, the British National Formulary. Ask him to look up what the dose is for suspected cyanide poisoning. And then ask him how common is suspected cyanide poisoning. So basically, if you as a fire person breathe in smoke in a burning building where there are furnishings and furniture in the burning building, then you will be treated for suspected cyanide poisoning the moment you come out. Because there's loads of cyanide floating around in burning buildings, burning furnishings. We manufacture stuff with nasty, well, I won't say nasty, we manufacture stuff with high quality products, and those high quality products on burning release cyanide. that fire people wear breathing apparatus, but if you're carrying someone down 3 flights of stairs, there's a very good chance that each flight you will take the breathing mask off, give your person you're carrying a few breaths, and then put it back on before carrying on to the next flight of stairs, so that when you do get them down, they're not poisoned. They're breathing much more slowly than you, so they're less sensitive to the intake of cyanide. But you will, as a fireman, you'll be using your breathing apparatus to help the person you're carrying. And when they get treated, it's 5,000 or 5 million micrograms, 5 grams of the stuff they get by infusion. So 5,000 times what you get in an injection. And they don't even get the rest of the shift off. They get this stuff pumped into them, and then they're back in action. So it is not dangerous 5,000 times for something that you could be getting every couple of months as a professional throughout your professional career. Shows that it's not dangerous in vast quantities at all.
Oh, he's not worried about the danger. He just doesn't believe in it, that it works.
So it's basically down to if you have genes on the walls of the cell preventing it getting from the blood into the cell, or if you have inefficient genes inside your cell, you just need much higher levels in order for it to actually work.
And they're not identifiable genes, or are they?
Well, we don't have the quality of genetic tests or the cheapness of genetic tests to go to that level of depth. But yes, what I was talking about in those slides, talking about the genes, the ABCD4 and the LMN BD1, those two helper genes which just do the transports across. There are alleles which have been identified, which you could look for. I didn't go into all the alleles because that would have been long and tedious and rather boring. But yes, they are documented.
I'd be curious to know from our group regarding the smoking. I think that is fascinating. My mother smoked very heavily when I was pregnant, and they then both smoked 40 a day each throughout my entire childhood. And I found it quite traumatic. I can't watch a cigarette in a film. I can't be with someone that smokes. And I'd never heard of that link before. And I've been looking up since you said it. It's really interesting.
There's a whole lot of things that have the same symptoms as B12 deficiency. There's a number of medications, including some for psoriasis, skin conditions, which have the same symptoms as B12 deficiency. And some bright spark decided to test people's B12 and found that the B12 was low. And they realized that a lot of the medications work by being poisonous. Obviously, they're designed to be more poisonous to the microbes than they are to the human host. But nonetheless, they work by being poisonous. And the first thing the B12 does is try to stop them poisoning the human host. And in doing so, that reduces the amount of B12 available for everything else. So there's a whole lot of things that have similar symptoms. Alcoholism has similar symptoms. And it turns out, of course, that it's not similar symptoms at all. It's that the alcoholism causes B12 deficiency, and the B12 deficiency has B12 deficiency symptoms.
Brilliant. Thank you for raising it. It's really interesting.
Thank you. Julie asks if there's a link between B12 and diabetes, essentially, insulin resistance. And B12 deficiency can cause autoimmune conditions. It can make your immune system not function properly. We have proposed a mechanism. We don't know if it's correct yet, but we have proposed a mechanism that because B12 is absolutely vital for membrane integrity, the membrane around every single cell, there's a likelihood that if the membrane isn't in perfect form, then the proteins that stick through the membrane might be at funny angles or might be the wrong way around. And the way the immune system works is it goes around looking at cells saying, are you part of me? So it's looking for a me protein that says, I am part of me. And if it can't find it on a cell, then it says, must be a foreign cell, and kills it or attacks it in one way or another. And if the membrane is distorted in some way because it's not perfect, it'll still be basically surrounding the cell, but the protein that says I'm me might be at an angle, which means that the immune system doesn't recognize it. And if the immune system doesn't recognize it, then it attacks it. That's the cause. Autoimmune is the cause of diabetes. And therefore, it's no surprise that there would be a connection between B12 and diabetes. I'm not saying B12 is the cause of all autoimmune conditions, but B12 is one of a number of causes of autoimmune conditions, and diabetes is one of the autoimmune conditions. That's why when you start getting autoimmune conditions from B12 deficiency, you get a whole lot. You start with one and you get a whole lot more. And pretty soon you've got the whole gamut. What else have we got? We've reached the end of our time. Can I recommend an adeno supplement? I can't remember what I use. I'll see if I can find it. From Amazon, of course. I'm lazy like that. Well, one reason I buy from Amazon is that a number of my friends work in the warehouses in Amazon, so I'm creating jobs for them. Sounds strange to say that this company that everybody thinks destroys jobs actually has created jobs for people I know. But then up here in the Northeast, we are going to be the pilot for drone deliveries. Let's have a look. Metabolics, vitamin B12, adenosylcobalamin is the one I'm using. So metabolics. Julia M asked, how do you know that you can't convert hydroxy? I found it wasn't working for me anymore. It's as simple as that. So I tried something different. And Sheila asked how much adenosylcobalamin daily. I take 1 capsule. They come in different concentrations, but I'm pretty sure they are far more than you could possibly need. So I just take 1 capsule. And Simone says maybe better to open them and eat them in a little yogurt. Absolutely. Simone is a nutritionist amongst her many other qualities, and so if she's suggesting that, I would say that's a good thing to do, and I might try that myself. They are quite small capsules, so they're probably a little bit fiddly. Yep. And Sue says that COVID spike protein was suspected of entering the cells in the same way as B12. And it was postulated that supplementing with B12 might help COVID patients as it would block the spike protein access. There's a whole lot of different ways that that B12 might help COVID patients. I hadn't heard the theory that it might block access of the spike protein, but certainly if it helps you be healthier, then it makes you stronger to fight off the symptoms and to fight off the virus. The other thing, of course, as I've mentioned about the cell membrane, is the spike protein has to get through a membrane. So the weaker the membrane, the easier it is to get through it. And if the membrane is as complete as it should be, then that would help you with all sorts of all coronavirus injections, all coronavirus infections, and of course the most common coronavirus infections are flu. So, which is it? Anyway, coronaviruses are very common, as well as the one in the particular form of coronavirus that was COVID. Trying to think if it is. One of them's a virus and one of them's a bacteria, and I always forget which is which. I suppose it's common cold that's the virus, and it's flu, the infection. Someone dig me out of my hole. I've dug myself into. But yeah, B12 might well help make you stronger and therefore protect you against COVID, amongst other things. I'm going to wish everybody good night. Thank you very much. Glad you've all enjoyed it. This will come up as a recording soon. This will be a little faster because I'm going to be a little bit faster about looking through the recording and approving it. Whereas some of our speakers have too many other things going on and don't get around to approving, and we can't publish till they have approved. I'm glad you've enjoyed it and very happy. We've got a whole lot more speakers, but probably in a year's time I'll do another talk on another specific topic, and we'll have fun with that. And obviously we have some people with a lot of knowledge here today. I'd be very happy if people want to propose themselves as a speaker on a topic related to B12. It doesn't have to be entirely about B12. Next month we have, I've forgotten the name, but anyway, talking about dementia, how to avoid dementia, how to postpone dementia, which is very closely related to B12. In fact, was one of the first of the big field trials of saying we can postpone and prevent dementia by giving tablets in Oxfordshire. Multiple thousands of patients were tested, and those who were on B12 had much later onset dementia than those who weren't. And what's more, they managed to show that it was connected with the brain shrinkage. Brains shrunk more without B12 than they did with B12 in older people. And I think we've got a speaker already arranged for June and July, so it would be after that that we'll then be looking to put the next speaker on. And I probably during the next talk, or maybe the one after, we'll also have a brief demonstration from Annie Barr on how to self-inject, which will also be good.
We've talked about injections and capsules, and I know there are drops as well. Have you come across B12 oils? I've put something in the suggestion in the chat about perhaps inviting somebody, because there's a chap in Australia who's selling B12 oils, and he's written quite a few papers about autism and chronic fatigue syndrome, and he's saying in certain people there's an underlying B2 riboflavin deficiency.
Yes. Well,
and that's something I've never come across from anywhere else.
Yes. So inevitably there's a huge number of things that interact. I'm reluctant to use the term cofactors because everything interacts with everything. That's just the way bodies work. So you could say everything's a cofactor, in which case the term becomes pointless. So yes, you can be deficient in all sorts of other things, and I use this leaky bucket theorem that I've talked about before. B12 is water soluble. I've heard people come up with various justifications for B12 oils, including someone who had a spray which was sesame oil with the B12 in it, and what they said is because the B12 doesn't dissolve in the oil, it's therefore forced into your bloodstream. So apart from not being totally convinced by it being forced into your bloodstream because it wouldn't go into the oil, I was also a bit concerned that he's selling sesame oil, which is one of the allergens, one of the things that a lot of people are allergic to. But absolutely, if you want to send me the details, I will be delighted to read up about it and see whether I think it would make a good speaker.
Well, it's just B12 oils, and you'll find it, and the guy's name I put on the chat.
Excellent.
I think it's Gregory Russell, PhD. And he's written quite a few papers.
Yes, yes. People with something to sell do write a lot of papers, I have to say. But yes, absolutely. Thank you very much. It is, of course, the middle of the night for them, but we might well persuade him to come. I know Kay often joins us from Australia in the middle of the night. But no, that's really good. Thank you very much, Jay. Thank you, everybody. Glad you've all enjoyed it. And do sign up for I'll send you around the details for the WhatsApp group and for the newsletter. Thank you.